again grant its high patronage to this event, a recognition that honors both the foundation and the broader Italian scientific community abroad. The formal partnership recently established with the Italian Ministry of University and Research further underscores ISSNAF's capacity to act as a true catalyst for new collaborative initiatives and joint projects. And the Italian Minister of University and Research, Anna Maria Bernini, has sent a message that will be later on read by Professoressa Cecchi, confirming her strong support for ISSNAF and for the growing bilateral scientific cooperation between the United States and Italy. This year, as we all know, has been designated the International Year of Quantum Science and Technology, and it is for us an excellent opportunity to strengthen the commitment that we all have on one of the most transformative frontiers of the modern science. I have been here for only 2 months, but had a great pleasure to visit the Fermi Lab, and I also went to other center of important scientific research and technology in Texas, in NASA, and I'm really counting to use as much as possible my times in the United States to meet our fantastic scientists and researchers and see how this is actually converted in impressive technological achievements in terms of the machineries and engineering feats that we can deliver in many projects and experiments. And this is, of course, very important not only for science, but also for the economic dimension of cooperation between Italy and the United States. And while I was observing the project this afternoon of the many brilliant researchers and scientists that will be then getting prizes, I finally understood what I'm going to do when I retire. I will try to understand 1/100th of what you're doing a bit better. And maybe it's never too late, I'm sure. So, of course, for us, we are also very proud to work on this domain because at the government's level, we have, as you know, the Italian National Strategy for Quantum Technologies that we just presented last July. This is a formidable platform to also cooperate with our American friends, and it reflects our ambition and long-term vision in this area. It's clearly the awareness that quantum is a key enabler of competitiveness, technological sovereignty, security, resilience, but it applies to all sorts of sectors, including, for instance, the biomedical sectors, health, and many others. So it's really one of these transformative technologies, and we are counting on the number of fantastic young researchers here to make a great advancement here. And we are aware that working in the United States offers to us possibilities that are of mutual interest and mutual success for both countries. Finally, I think I'm simply delighted to add that this year annual events of ISSNAF will also try and link more and more with not only with the university research centers, but also with private companies to explore the operational dimension of what you're doing. And I think that this is the spirit that we always try to have in the work with the colleagues, because all we do at the end of the day has to be connected in what is a bit our tradition as Italians, as a culture that has a holistic perception of what we do, our stile di vita, our nutrition, our values, our savoir-faire. It is all connected. So it is important never to be sectorial. It is important to exchange. It is important to meet. And in this spirit, I'm really very happy to have you all here. I'm sure you will have a great time and many good things, ideas, projects come out. And once again, welcome and have a very fruitful discussion. Thank you, Professoressa. Thank you.
Thank you very much, Ambassador, for your inspiring words and for your continued commitment to support the Italian scientific community in the United States. So, as anticipated, it is my pleasure to share with you a message from the Italian Minister of University and Research, Professor Anna Maria Bernini. Cari ricercatori e ricercatrici, dear researchers, I extend my warm thanks to Ambassador Marco Peronaci for hosting this event and to President Cinzia Zuffada and ISSNAF leadership members for sustaining a vital bridge between Italy and the United States. Thank you all for advancing science and technology for the benefit of society. I'm also glad to see the focus that has been chosen this year for your annual event, Quantum Technologies. Italy has recently launched its National Quantum Strategy, a milestone that positions our country at the forefront of this transformative frontier. The Italian vibrant community of the quantum has been fully involved in the process and will see important developments in the coming months and years. Collaboration with the US within a strong EU framework is, in my view, extremely important. Another important step has been the adoption of an Italian national model of research security, with voluntary guidelines to ensure open, responsible, and secure scientific collaboration. Starting from August 2025, a dedicated national website serves as the public hub, providing transparency and guidance for researchers and partners alike. Again, also in this case, we fully share the process with our scientific community, in line with our G7 and EU commitments and best practices. Investments in science are growing, and my ministry is strongly advocating within the government for research funds and a more flexible and attractive working environment, with an easier way to promote technology transfer. From this point of view, we look at your experience in the United States as a key example and driver for discovery and growth. In this context, I wish to underline a simple message: choose Italy. Choose Italy as a partner for innovation, for science, and for trust. We are committed to fostering forward-looking research collaborations with all our best international partners. Looking ahead, the next Joint Commission meeting, confirmed by the Department of State to be held in Washington in spring 2026, will be a crucial opportunity to strengthen this dialogue. I sincerely hope to attend in person to contribute directly to our bilateral and shared transatlantic agenda. Before concluding, I want to acknowledge the wide network of Italian science attachés across the United States, coordinated by our embassy in Washington and embedded in our consulates. We reinforced this network in order to create new bridges of opportunity. It is of utmost importance that ISSNAF works with them on a daily basis. Finally, let me express my full support to our new Italian ambassador in the United States, Marco Peronaci. I'm sure that he will further promote science, innovation, and technology, fully aware of their strategic and growing importance for both the economic and geopolitical future of our nations. Thank you, grazie e congratulazioni a tutti per il lavoro che state facendo. It is now my pleasure to invite to the podium Professor Cinzia Zuffada, President of ISSNAF, whose leadership and dedication have been instrumental in guiding the foundation and in fostering the remarkable network to bring us all together today. Cinzia,
welcome everybody, and thank you for joining us today to celebrate the Italian diaspora of scientists, scholars, and innovators in North America. Let me start by expressing my gratitude to Ambassador Peronaci and to Minister Bernini for their remarks that convey the appreciation that esteemed representatives of the government of Italy have for our community in North America and for our foundation in particular. It is our introduction to Ambassador Peronacci, and you have already shown us the graciousness of accepting to be the chair of our honorary board of directors. Thank you for your trust. ISSNAF counts more than 3,500 members. They are professionals working across all disciplines of scholarship and innovation, and our mission is to connect, empower, and celebrate this community. The gathering provides a special opportunity to connect our community across many different fields, engage in discussions around important themes. This year, it's the quantum technologies, celebrate the accomplishments of early career researchers and innovators, as well as honor an exceptional individual with the Lifetime Achievement Award. Collectively, our community represents an unequaled wealth of knowledge and experience, resources that can be leveraged impactfully for the good of the people of both the United States and Italy. Many of our members hold senior positions within their institutions and serve as ambassadors of Italian talent in North America, are catalysts of collaborations across the Atlantic, and role models and mentors to younger generations of researchers and innovators. One important ISSNAF goal is for our collective expertise to be leveraged by Italian institutions, such as universities, companies, foundations, and other entities interested in expanding their networks in North America to access expertise and innovative thinking that can support the development of Italian ecosystems of universities, incubators, and stimulate entrepreneurship. One key pillar is represented by researchers' mobility through exchange programs and increased collaborations to help enrich, accelerate, and expand the training of the next generations of researchers and managers of R&D in Italy. Starting in 2023, the Italian Ministry of University and Research, Office of Internationalization, has funded our efforts to develop the infrastructure of a national-level system that allows streams of Italian students and new graduates to connect with ISSNAF members willing to host them at their research organizations in North America for periods of study and research collaborations. Back in May of this year, we presented our program at a conference of representatives of Italian universities organized in Rome in collaboration with the ministry and the CRUI to socialize it and encourage its adoption, receiving a very positive welcome. We also have strengthened partnerships with Italian foundations dedicated to supporting academic research in selected strategic areas and their transition from research to entrepreneurship of university spin-ups or other type of startups. Besides our ongoing partnership with Fondazione Marche and their AC75 accelerator, a sponsor of the launch at our event, we have added a new partner in the Tech Europe Foundation, TEF, based in the Lombardy region. Their goal is to increase competitiveness in innovative technology-based sectors of the economy, and the partnership with ISSNAF allows them to tap into the technical expertise of our members and involve them as advisors to support their project selection processes. Thanks to the engagement of these new partners, ISSNAF is debuting this year the Innovator Awards. It's a series designed to recognize outstanding Italian researchers and innovators in North America who have made significant contributions by bridging scientific excellence with entrepreneurship, ideally impacting both sides of the Atlantic. We are grateful to both AC75 and TEF for their sponsorship. These activities give us confidence of the value that ISSNAF offers to the Sistema Paese, and we are energized by the opportunity to scale up our organization and increase our impact. Our network of chapters continues to grow with the addition of Idaho and Quebec, and with that is our ability to engage with more members and increase the reach of the programs that we offer, such as mentoring, advising, and mobility. In fact, the chapter members can act as multipliers in developing contacts with institutions and other potential partners interested in making Italian innovation better known in this part of the world. And now I conclude by thanking the many volunteers and collaborators who support ISSNAF in any and all of these activities, including those leading to today's event. Your work is making a difference. And finally, many thanks to the Embassy for the gracious hospitality and their generosity to the event speakers, the panelists, the finalists, the award chairs, and last but not least, the scientific attachés who have actively worked for us to support the preparation of this gathering. Thank you. And now for a change of page, let me open up the session on discussion on quantum technologies. We have the first contribution that is provided by Professor Tommaso Calarco, who is joining us remotely from the University of Bologna in his role as the National Quantum Strategy Coordinator for Italy. Professor Calarco, you have the floor.
Wonderful. Thank you very much. Your Excellency, Ambassador Peronacci, ladies and gentlemen, it is a great pleasure to be here for me today. And thank you for allowing remote participation for a series of reasons. And the first one is that of all Italian diaspora in the United States, I probably am the one which geodetically was closest to the embassy, because I have been living for 1 year next door, literally, to the embassy in Whitehaven Street, 3100 Whitehaven Street Northwest in Washington, D.C. So at the Center for Hellenic Studies, where I was following my wife, working, doing some research there. And that was more than 20 years ago, and we still have enormously fond memories of the time there. So it really pains me not to be there. But a second reason, which is very important and maybe more central to the content of my talk, is the fact that Minister Bernini, when she asked me to coordinate the work for the Italian strategy, this is something which she got inspiration from one of her last visits to Washington, D.C., accompanied by the predecessor of Ambassador Peronacci, and she realized the opportunities lying in the possibility of leveraging the excellence and competence and expertise that we have in Italy in order to carry out science diplomacy, we could say, and technology diplomacy with the United States as well as with other countries. So this is why I am moving on in the next 10 minutes that I was given today towards essentially speaking about, and I think that you are seeing, yes, I see on the screen that you can see my screen, speaking about the Italian strategy for quantum technologies in the European context, also according to the two flags that I see prominently next to the United States flag in the conference room. And so this is also taking steps from the European Quantum Flagship, which is now moving into a new program, Quantum Europe, which has been declared with a communication from the Commission to the Parliament and Council, which was actually relying on a joint declaration between the European Commission and all member states of the European Union to a so-called Quantum Pact, which was moving towards integrating the all the national strategies of member states, including the Italian national strategy, into the European stream of activities on quantum technologies. So what I want to do in the next few minutes is really to show you what are the contact points between what we are having at European level. And here, of course, we are speaking about the different areas is not just quantum computing, which is maybe very present in mainstream media, but also quantum simulation, quantum communication, quantum sensing and metrology, and really, very importantly, relying on a strong basis of basic science. And this is moving towards new activities and new infrastructures. For instance, the European quantum communication infrastructure, which you are doing at European level, as well as the European quantum computing and simulation infrastructure in the context of the joint undertaking for high-performance computing at European level. And also, of course, connecting with the capabilities for creating chips with the European Chips Act. And actually, you will notice that a lot of this has a counterpart in the United States with the Quantum Information Act and also the Chips Act at US level. So really, there is a synergy, I would say, transatlantic, but also between the European and the Italian strategy. So we started from this flagship, which was really mostly centered on research. And then we are moving, you see, towards the right, towards infrastructure and industry with the deployment of quantum communication and quantum computing, really for the benefit of European society. And also with developing a quantum fund, which is really something on which we must admit the United States are very much ahead of us in terms of, also private investment supporting the startup and scale-up ecosystem in quantum technologies. So what are the action lines that we are having in this context? Of course, they are connected to all these fields that I mentioned before, plus some aspects which also are conducive to international cooperation, such as standardization and benchmarking, in which international cooperation is really essential. And there are recommendations that we put forward, which I'm going to illustrate in the next few slides, in connection to what is the European strategy. So Italy is, even though it didn't have yet a national strategy before Minister Bernini decided to go in this direction, already had a lot of activities with the Resilience and Recovery Fund, which invested more than 220 millions in the last few years for different kinds of projects, with a couple hundred projects, with several calls across the country, and with really a lot of excellence and competence distributed throughout the country. You see really, in the north and in the south, there are very many places with a substantial critical mass, also distributed along different application areas and along different platforms. We don't have the time to go into detail on that now, but of course, I'm happy to provide the detail, and you will find, of course, details also on the website of the ministry. What I want to do in the last, let's say, 5 minutes, the second half of my talk, is really to show how our Italian activity is really very much a counterpart, a pendant to the 5 areas which we have in the Quantum Europe strategy, which our European Commission Vice President Virkkunen has announced in the last summer. Actually, in the context also, very, very close to a meeting that she was having when she was visiting Italy and meeting our Minister Bernini. Of course, the foundation of all the activity is research and innovation, which means scientific discovery, really translation in sense of building industrial capacity, and also making the use of those devices available for our society. And in Italy, of course, we are putting a lot of accent on strengthening this research ecosystem and also coordinating this funding in order also, someone said before, choose Europe, choose Italy and choose Europe, in the sense of attracting and establishing a stronger bidirectional exchange, so to say, also with the United States as well as other countries. If we speak about infrastructures, we already mentioned before the computing infrastructure and the quantum communication infrastructure, but also other activities which are starting now about deploying, for instance, gravimeters for monitoring of resources such as underground water, or also for monitoring of volcanic activities and prediction potentially of eruptions and of earthquakes. And this is something which has to be deployed both to make quantum innovation available to society, but also to bootstrap the market in order to really make our startup ecosystem and industrial ecosystem grow, to make it more and more mature. And so also here, there is a lot of alignment between what we are doing at Italian and at European level. And of course, this obviously requires proper financial instruments to be realized. So in this sense, not only we are thinking about specific instruments really and investment possibilities to support the growth, but also we are thinking about ramping up our independent Italian and European capability at European level with pilot lines to create quantum chips and really the possibility for our startups to produce their devices at scale, and at Italian level, of course, contributing to that, but also in terms of developing skills which are going to go into feeding that system. Of course, aspects of intellectual property and also standardization and benchmarking are very relevant here, and this is one area in which, of course, an international collaboration is not only desirable, but also appropriate. If we speak about skills, well, of course, you know, the level of training of Italian students is very, very high, as we all know. They are very much in demand across the globe and across Europe. And this is, of course, also a very important contribution to what we are going to do in terms of the main bottleneck for our both research and innovation ecosystem, which is talent, the need for well-trained workforce, which will be able to really address those challenges. And so this is in our recommendations at Italian level, not only, you know, higher education, but also in schools, but also retraining, upskilling, reskilling for the industry, and also in order to spread awareness and competence and knowledge about these fields in such a way that also our decision makers can be able to, you know, make proper decisions, not just informed by, let's say, industrial hype, but really based on facts. Now, one new element in the which was already, of course, present in the United States, but in Europe is coming with this new strategy, which will be also translated next year into a Quantum Act, so a European-wide legislation for a broad Quantum Europe Research and Innovation Program, is, of course, also the aspect of strategic autonomy in security, defense, and space. So here, the interaction between the civil research and defense, which in Europe and in Italy has been, you know, something more, you know, for some time, even for a scientific community, I could say even more of a taboo, much more than what has been the sort of the exchange which took place over the several previous years in the United States. Now, this is something which is coming into awareness, both for society, but also for the community. So in this sense, we do not have a dedicated section in the Italian quantum strategy for defense, but our Ministry of Defense, together with the Ministry for University and Research, so the portfolio of Minister Bernini, but also with the Ministry for Enterprise and Made in Italy, as well as the Ministry of Economic Affairs. I mean, also the Ministry of Defense has been deeply involved in this development. And so this is really a strategy which is coming. And this is somehow a unique feature from a collaboration between the scientific and industrial community, as well as directly involved in the working group and signing the strategy are not only quantum specialists from science and industry, but also from all these ministries. And this is a very promising step, because the recommendation, we are very optimistic that it can be adopted at the national level. So, of course, there is the very important aspect, which is especially relevant in the room in which we are sitting, in which there are the three flags, the Italian, the European, and the US flags of international cooperation. We have been promoting in the past, especially with like-minded countries. For instance, in the context of the Trade and Technology Council, TTC, a specific working group on quantum technologies. We also have a working group on quantum technology in the context of the G7, in which I have the honor of representing Italy. At NATO, we have a transatlantic quantum community, in which I'm also representing Italy. I'm a member of the delegation, you know, to really create also across the Atlantic some connections and some cooperation. And for sure, our national government is very strongly interested in that. And the way in which we want to bring this together with a strong synergy between the member states and the European Commission, creating critical mass in what we are calling national quantum competence clusters. You could call them a little, you could call them like national CERNs or national labs. And Fermilab is an excellent example of a national quantum competence center in the United States, which is certainly an inspiration for us in order to move forward. You have heard that my telephone has signaled to me that my 10 minutes have come to an end, and therefore I just wanted to show you this last slide, which summarizes the idea that we really want to combine at European and Italian level scientific excellence with industrial strength in order to achieve technological independence and being able to achieve market impact, in a way which is very much aligned and also in cooperation with our like-minded partners across the ocean, for instance, in order to build a common digital and industrial future. And with this, I have finished my presentation, and I thank you very much for your attention.
Thank you, Professor Calarco, for your insights. And I now move to introducing the panel. We have a panel discussion. Let me call Professor Alou to the podium, who is the Einstein Professor at City University of New York and also the chair of ISSNAF Scientific Council and the chair of the moderator of this round. Thank you, Andrea.
Thank you, Cinzia. As the chair of the Scientific Council of ISSNAF, every year we are in charge of selecting a team, also in collaboration with the embassy, for this annual event. This year is quantum technologies. We have just heard how important this is, how the field of science is developing and is moving along together with the impact on technologies. We have a panel discussing the present and future of quantum technologies. The panel aims at highlighting recent advances and future opportunities in the growing field of quantum technologies, spanning across sensing, computing, and imaging. And we plan to discuss outstanding challenges and opportunities for basic science, breakthroughs, and industry applications, both within the US and with the Italian communities. We have a great representation. I want to introduce the four panelists. Dr. Anna Grassellino, Director of the SQMS Center at Fermilab. Anna Grassellino is a leading expert in superconducting radio frequency technology and quantum information science. I suggest maybe Anna can come and present, yes, a couple of slides.
Well, first of all, thank you very much to Ambassador Peronaci and to ISSNAF and all the team here for this invitation. I think there was some problem with my slides, so I will just move my hands a little more and tell you that. So I am Anna Grassellino, I'm a senior scientist at Fermilab. I serve as director of the SQMS Center. We are one of the 5 national quantum centers that are funded by the Department of Energy. These centers actually, it's the news of just a couple of days ago. They were just renewed with an investment of $625 million for the next 5 years. So we're very excited by that. We bring together about 43 partner institutions. So Fermilab is the lead institution. The goal of this center is to really create bridges across industry, academia, and national labs. And they're multidisciplinary, multi-institutional centers that really bring expertise at 360 degrees. As you know, and as you will hear more in this panel, quantum information science is really an interdisciplinary field. You need to bring to advance quantum technologies and to demonstrate the power of quantum for important applications. You really need to bring together in a mission-driven type of collaboration experts that come from material science, from particle physics, from condensed matter physics, from computational sciences, and much more, all together, really with a focus on advancing these quantum technologies. So this is part of what our SQMS Center does. I will tell you a little bit more during the panel, but let me just mention one important thing that is really in the middle of my heart, which is among these 43 leading institutions, out of which 11 are actually leading companies in the quantum space. Actually, one of the core partners is actually the Italian Institute of Nuclear Physics. Italy is a very important contributor in our collaboration, and together with them, we actually work hand in hand to advance the so-called coherence, the quality of qubits. We do measurements, exchanging state-of-the-art quantum devices between the United States and Gran Sasso laboratories in Italy. And we also work together with their expertise to advance quantum algorithms and applications in fundamental physics that quantum computers will actually revolutionize. So just to say that Italy is a very important partner in this endeavor.
Our second panelist is Tommaso Macri, Senior Director at Quera Computing. Tommaso bridges quantum research and business development, advancing neutral atom quantum technologies.
Good afternoon, everyone. Thank you so much, Ambassador, Embassy team, and organizers for the opportunity to be here. I grew up academically and personally in Italy. I studied in Padova, then I did my PhD in Trieste at CISA, and then I traveled across Europe, South America, and I landed in Boston 4 years ago to spend a sabbatical year at Harvard, and then I joined Quera Computing. At Quera, our goal is to build and commercialize a quantum computer based on a specific technology called the neutral atoms. We'll hear more during the panel. But the big goal is really to start looking and solving really truly intractable problems, even for the most powerful supercomputers today. We identified essentially 3 main stages of this path. So basically solving some foundational capabilities for these devices, addressing one of the most pressing problems for quantum technologies, which is solving or basically overcoming noise and errors of these devices, and then bringing these computers to scale, to true adoption across several business and scientific sectors. All of these cannot happen in isolation or in a vacuum. We really need a strong quantum technology ecosystem. We work closely with Harvard and MIT, which are our closest academic collaborators, but we also work very closely with Italy. We have a strong collaboration and partnership with Banca Intesa and Links Foundation in Torino. We work with BIP, which is one of the strongest technology system integrators in Italy, and with several universities and research centers. In particular, I would like to highlight our recent collaboration and partnership with the Italian Center for Supercomputing and Quantum, which was funded with the resources of PNRR and led by Professor Antonio Zoccoli, who is also the president of INFN. So we really believe that these very strong collaborations and partnerships will position Italy at the forefront of this new technology revolution. So with this, I would like to thank you, and I look forward to the discussion during the panel.
Our third panelist is Dr. Stefano Poletto, Director of Quantum Engineering at Rigetti Computing. He's a veteran in superconducting qubit research and quantum processor development.
Thanks everyone. So I would like to start by thanking ISSNAF and the embassy to invite me here. It's a real honor to be here talking to you all. I was really inspired by all the papers and the presentation I saw outside. I learned definitely a lot. I didn't know I was so ignorant in this field. Anyway, a little bit about myself. I got my master at the University of Padua. I started in 2003, 2002 working with superconducting qubits. It was the beginning of quantum, right? When I started one, people were asking me, what is quantum computing? It will never work. And I said, yeah, but it's quite interesting. And I went on the only group in Italy was doing quantum computing at the time down at the University of Rome. I did my master there and then I stayed for the PhD. So I got a PhD from the University of Rome 3 in 2007. And then I moved a little bit. I went to Germany. I went working at IBM in Yorktown Heights. So the group of quantum computing, it was a very beginning at that time. And then I moved back to Europe, to the Netherlands, when I have the opportunity to work in collaboration with Intel. And finally, I joined Rigetti roughly 8 years ago. I work with individual contributor, manager, and now director of quantum engineering. My focus is mainly of next generation devices, so medium and long-term research in superconducting qubits. That is where I come from. What is a little bit special here is that I have a little bit of opportunity to see the field from inside, from the beginning. So I saw growing the field when it was very smaller to the size it's now. And then I have the opportunity to work in academia, in a big company, and in a startup as well. So I know what are the differences one each other and what motivates people working one of the other. So if you are interested to know a little bit more the difference, if you are interested to the next career step, I can definitely tell you what are the pros and the cons of each place where you want to work. You really have to fit with you, essentially. So one slide only. I tried to summarize here what is the field and what we see next. It's impossible to put everything in one slide. I can just stay here for the entire day just to talk about one topic. So what to me is important is just to tell you the superconducting qubits are artificial atoms. So they behave like atoms, ground state, excite, and more. So they have multi-level atoms and they interact with electrons. What we really like is that they are artificial in the sense we can design them. We can design what are the frequency they work, the coupling they work. So we can go on our equation, write the system, and then we fabricate them. We fabricate them with the same technology that is used to do our cell phones, microchip technology. The materials, as Anna said, are pretty different. There are some important things that we need really to consider. Anna knows well the difficulties here. But what is important is we have the technology, we have the machine to do this one. That's why we call them artificial, because we can design what we like most. The artificial atoms, went a long way. When I started, they were living roughly 1 nanosecond. It was 1999. First demonstration of superconducting qubit that was really controlled. It was living for 1 nanosecond. Now we have probably 25 years into the research, and now they live up to 1 millisecond, even more. So we have 1 million other improvements. We started with not having 1 qubit, and now we have a processor that is quite on the field, up to 100 qubits up there. So the field moved really a lot. I put there a couple of images. The top images, the first 2 images on the top is one of our processor. The real top is the wiring, so that can host 36 qubits. And the center image is just assembling. We are assembling unit of 9 qubits in the big processor. So those are 36 qubits. They need to be cooled down. So you probably are used to see the last images, like a fridge. In reality, the device is at the bottom stage. If we want to scale up, what is the future? The future to me is bright, is scary, and it's quite exciting for us, right? We have to improve way more. Coherence time, right? High fidelity, qubit counting. We have hundreds. It's not enough. We need to go, if we want to really consider a universal machine, we need to go to millions of qubits. And at that scale, the fridge cannot operate, the wiring cannot work, the way we do the chip doesn't work. So we have to invent completely. Everything is new up there. The processing information is difficult. So there are area of research that span from physics to engineering to cryogenics to quantum computing. So that is the exciting part for me. There are plenty of work ahead of doing it, and we're pretty excited about it. So I hope you will enjoy as I do.
Our fourth panelist is Professor Massimo Ruzzene. He's the Senior Vice Chancellor for Research at the CU Boulder. And Massimo is an expert in wave propagation and metamaterials, driving interdisciplinary research and innovation.
Thank you, Andrea, and thank you, Ambassador, and thank you to ISSNAF for having me here. This is an honor. Unlike my fellow panelists, I'm not a quantum scientist, but I have the privilege of leading the research enterprise of the University of Colorado Boulder, and quantum for us is a major part of our portfolio. And 5 years ago, we launched this initiative that is nicely called Qubit. CU stands for University of Colorado, BIT, and it's an umbrella organization who really brings together all of our strengths in quantum technology. To give you a reference, we attract about $50 million in federal funding every year in this area. These are the technical disciplines that they cover, but I would say quantum sensing is and timing is really an area of core strength for our university and for our region. The pillars of the initiative are discover, educate, and commercialize. So I talked about the discovery side, but we have the biggest graduate degree in physics in the nation, and a lot of it is in quantum science. And we launch, on average, 5 startups every year in the quantum area. It's a growing ecosystem. It's centered at the university and centered at NEST, which is less than a mile from my office. We had for 60 years a joint institute, it's called GILA, which it combines researchers from the university and from NIST. That has led to a lot of breakthroughs in this area, 4 Nobel Prize winners, and continues to develop and advance the technology. And in recent years, just in the last year and a half, we attracted almost more than $200 million in funding in quantum in support of a development of a national quantum nanofab facility. We were designated as a tech hub for quantum from the Department of Commerce, and we launched a quantum incubator, which is a place where startups, researchers, and federal labs can work together, testing technology, developing test beds, and promoting workforce development, because it's a really key component of the work that we do. We're not on the coast, but we are a very important player in this field, and we're happy to talk more about interdisciplinarity in this area. So thank you.
So we're ready to start the panel. We will have some questions to break the ice, and then we will open it up also for the audience. So my first question for the panel, as you see, is very interdisciplinary, and there's also a nice combination of industry and academia components. What are the most promising applications of quantum technologies that you foresee and their impact in the next 5 to 10 years? Tommaso, you can start.
Can you hear me? It's better like this? Okay, excellent. Yeah, so I mentioned in my address that the goal of quantum computing is not necessarily to solve problems that can already be solved by classical supercomputing systems. That would be kind of easy. And the expectation is actually to start looking at those issues of those both scientific and industry problems that are really intractable to current existing platforms. And when I talk about platforms, I really talk about standard CPUs, GPUs, or supercomputers made of even thousands of these classical devices. In general, I would say it is true that today quantum computers are still a kind of an emerging technology, in the sense that the technology readiness level is still very low, at the level of 3 or 4, so very close to kind of academic applications. But you can already start using those to make simulations that are relevant for scientific applications. So for example, start looking at very simple scientific problems, simulation of very small materials. And this could be done in both analog and digital devices that are already available today. But of course, the big promise is start looking at, quantum chemistry problems, pharma, or drug design, drug discovery, or applications, for example, in cybersecurity. One of the most important applications that started to kind of boost the field, at least from the perspective of what was the area about 20 years ago, is the problem of factorization. Factorization is at the core of our, password and our security of our quantum of our devices, like our cell phone, our bank account, and so on and so forth. So there are algorithms that in principle could be run on quantum devices, but still the technology is not yet there. So these are, I would say, at the very high level, the applications that could be addressed by computers.
I found interesting that all 4 of you in your pitch mentioned the importance of the synergy between academia and industry. Maybe as a follow-up, Massimo, any comment on this synergy and on what you guys are doing at City Boulder?
As I mentioned, we have just developed a quantum incubator. And I think, to me, taking the technology outside of the laboratory is what is really critical at this time. And quantum technologies, as we were hearing, holds a lot of promise. But if we don't think about how we translate the fundamental advances in condensed matter physics, atomic, molecular, and optical physics into devices, this technology has a risk of never living up to its promise. And it will be all of our responsibilities to do that and making sure that we capture those. And so for us is really thinking about what are the bottlenecks in terms of starting companies. And first of all, we need the fundamental science, and we need the education to bring up the discoveries and advance them. Then we need to think about what's next. And what's next is understanding the applications, connecting the scientists, fundamental science with the engineers, developing devices, and then providing the space for development. So for a startup in this area in particular, the initial investment is pretty steep. And so how can we make sure that a company that starts off from a lab as a single postdoc student has the ability to test de-risk technologies? So providing equipment, providing space for collaboration is key. And the last piece is connecting with not just academia, industry, and the federal labs, which are very, very strong, very present in our area, in the area, Chicago area is the same. That connection is also really, so building bridges between institutions is also really.
I was wondering if Anna can add on what are the biggest challenges that you have seen in this role in bridging this type of interactions between academia and the research labs and industry.
Yeah, first of all, let me just say that I agree fully with Dr. Ruzzena. This is exactly the concept I was explaining earlier. I mean, these quantum technologies are so complex and require so many experts and advanced tools in so many different areas that really it requires advancing in this field that requires taking all of the field and all of the institutions type of approach. And if you want, you can call it maybe sort of like a Manhattan project type of approach. Practical example that I can give is the strong relationship that we have developed, for example, with Rigetti Computing. Rigetti Computing has been a partner of Fermilab since 2019, I believe. And at that time, Rigetti was still a startup. Now has grown to be actually a fully traded company. But the concept there was that they were already developing quantum processors. I think at that time, maybe they were 40 qubits. Now we are approaching 100 qubits. But what a startup or even, a very large company can do, it's in a sense limited as compared to, for example, what a national lab can do in certain areas. And one of the things that is very important that was mentioned by Dr. Stefano Poletto is, for example, how do we improve the quality of these devices, the coherence, how we need to be able to manipulate and sustain these quantum states for as long as possible. That is a problem that really revolves around the material science of understanding the nanostructure and improving these devices. And there, investments that the Department of Energy, for example, has made over the years in the National Lab Complex, which ranges from very advanced microscopes to, if you want, ginormous microscope, which is particle accelerators, really shines because we take, for example, the qubits that Rigetti makes, and then we cut them in pieces and we put them under this very advanced microscope or under light sources. And we outline, we highlight to them what defects are there and how to build better component. So this is just an example. You asked me, what are the challenges? Of course, there are challenges often revolving around IP. Companies want to maintain, the secret juice often. But I think what has been really exemplary in the partnership with Rigetti has been that actually in certain cases, it pays off to be open. Rigetti has always been extremely open. We are collaborators hand in hand. We go to their clean rooms, they come to our laboratories, and there is no secrets. We're fully transparent. And that has helped them go from this level of fidelity to this level of fidelity. So the more you actually open up, the more you take and you gain.
So for this is important also this vision that comes from long-term government funding that has supported this. But crucial is this talent development. So being able to bring the next generation of scientists working in a field that is highly interdisciplinary. All of you have mentioned the need for materials, for technologies, for design. So maybe Stefano, do you want to comment on what are the challenges in creating these types of synergy between industry and academia to build the next generation of?
Yeah, sure. It is now, right? So yeah, we have two main challenges in this area, and definitely is talent. There is clearly shortage of talents, and the communication even between different talents. Right? So the first comes from the fact that the field grows a lot in the next 5 years, I would say. Right, 10 years ago there were probably a bunch of companies, 3-4 companies, right, doing quantum computing, and now you count more than hundreds of companies. Most of them are startup, are smaller, right? Spin-off university, the PhD student that is motivated, has finished, he want to do something, and he challenges himself. So this means that everyone is looking for those talents, and the university, the institution, was not able to catch up. It takes a year to prepare, right, the next level on the new technology. So there is this strange situation nowadays where the industry, even probably academia, is looking for more talents, and there is a shortage, a real shortage of talent out there. What we experience, moreover, as a company, it's the communication between them. We are entering in quantum. It's new for the physicists. That's been there for a while. It was it's what we call a physicist's dream to build this machine, and now it's becoming an engineering challenge. So it means we have to plug into knowledge from all other fields, and we do not know how to communicate with them, and they don't know how to communicate with us. As an example, the way we build electronic, right? The way we have electronic to control our devices is not the same to control a normal bit, a classical bit. Even a fan that is there to cool down the chip in the electronics, right, to not overlap, it can destroy the quantum state. And we clearly see in our qubits, we can see when the fan spin up and spin down. We can even count the frequency is rotating sometimes. So it's really delicate because engineering doesn't see why that is important, and we don't have the knowledge to explain to them why it's important. So having a university or institution that prepares not only vertical, but even horizontally, right, to communicate between us, them, for us will be extremely valuable.
Yes, I think that's something that we thought about very deeply in the last few years, and the workforce development is what is very important to us. It's a university. We conducted a study with companies in Colorado. We brought together about 10 companies in quantum space, and we asked, what is the need that you have in order to grow? And they did obviously say higher level degree, people trained, high level of training, but they also said that they really need experts in building their labs, expert in optics, laser, machinists, and lab technicians. So it's a whole spectrum of levels of education, and companies uniformly said that this is probably the biggest need, not necessarily more PhDs. Yes, those are really important to advance the knowledge, but also different levels. So we're partnering with community colleges, for instance, and developing degrees at the undergraduate level and master degree level, because as we scale up, that's going to become a bigger.
Anna, you mentioned before this interesting synergy between Rigetti and your institute. Are there other examples, or maybe even institutional ways? I was curious first, how did that start? Was it just a need issue? You found each other, or there was some institutional drive? And there are other examples of or support at the higher level to incentivize this type of interactions within industry, research labs, and also across continents.
Yeah. Well, I think that now you ask me, I'm trying to remember how this partnership with Rigetti started. I believe it really came out of, it's very important in the scientific field to publish. And so Fermilab has always been very, very well known for being a leader in the material science that pushes what we call the quality factor, anyway, the quality of the superconducting devices. So that's kind of our background. We, for years, built particle accelerators that had very, very high quality, very high coherence. And that problem, their expertise is directly relevant to what actually Rigetti needed in terms of advancing the quality of superconducting qubits. I believe that's sort of, and possibly I think we had a person that we hired that was kind of like a crossover. And so that was the first bridge. You asked me, how do these partnerships, that said, we have a center with 43 partners. So how did we get there? I mean, there is always a nucleus that starts. I think our center started again around, we built it upon particular strengths. We said, our goal is to advance the quality, the coherence of superconducting quantum devices. And then we built our collaboration and then deployed this better performing devices to advance particular applications. And then we built the collaboration around that. Rigetti, that's an example. Northwestern University, for example, we had a center that was for applied physics and superconducting technology. There was a joint center between Fermilab and Northwestern, bridging academia and national lab, and that was part also of the core of the foundations of SQMS. And then, for example, we knew the material science was very important, so we asked Ames National Laboratory, it's a DOE national lab that focuses entirely on material science. So we asked if they were interested. They never did quantum before, but they brought, again, back to the workforce. We need, I think what we are doing actually helps tremendously because we need those vertical, deep experts to then come understand what the problem we're trying to tackle is, and then bring in that expertise that otherwise wouldn't exist. That's just some example. So we looked for key partners, and in certain cases, key partners looked for us. Another partnership I'm very proud of is actually IBM. IBM is another company that actually builds leading superconducting processors. With them, we don't work, with Rigetti, we work more on the materials and the quality of the qubits. With IBM, we work on scaling. So they make already very, very high quality processors, but we have the expertise to help, for example, link this processor to scale to thousands to millions of qubits. Again, Italy, how did that, actually, maybe I'll close with that. How did the partnership with NFN come? It actually was born here. It was born at the embassy, exactly in a meeting similar to this. It's the yearly bilateral that is organized here by the embassy. And we sit down together, Department of Energy and Italian Institute of Nuclear Physics, and we discussed, how could we collaborate to accelerate? And there was enormous interest. And this is actually how the collaboration was born and became part of SQMS.
Yeah, absolutely. This in the importance of institutional fostering these collaborations and also leveraging the initiatives in every country, right? There is a lot we heard about Italy, Europe, US, of course, also Asia is growing a lot in this area. So leveraging this long-term investment important at the international level.
But maybe if I can add, I think you asked me what can accelerate. I think the investments that have been made under the National Quantum Initiative, really in putting emphasis on this, on the multi-institutional, right, multidisciplinary collaboration needs. I think that is really obviously what has helped accelerate.
I want to know how are we doing with time? I know we started a bit. Yes. So that was my goal as well. So we open it up for questions from the audience. Any curiosity or questions from? Yes.
Yeah, that's a great, that's actually a great question. One of the pillars of typical now collaborations between the industry and quantum computing companies somehow is also around the relationship between AI and quantum. In our case, we have a strategic collaboration with NVIDIA, for example, specifically on the use of AI to better predict the role of noise and therefore of the errors that occur in quantum computers. And this is AI for quantum. There is also the other way around, which is also very relevant, which is quantum for AI. For example, to train new LLMs, new large language models based on specific data that could be captured or can be created or simulated with quantum computers. So the quality of the data is critical in order to predict or new images or new, for example, compounds, if you're talking about material science. And certain types of calculations can only be done today with quantum computers and will only be done by quantum computers definitely in the future. So I would say quantum for AI and AI for quantum is definitely a very important link that will be explored more and more over the next few years.
Yes, another question.
No, I think if I can say very briefly, and I'll let the others also, maybe more the other way around. I think the fact that we are trying to advance quantum computers, quantum sensors will actually, as a consequence, help potentially, discover something new, something different in the world of quantum mechanics. Some of the things that we have done at SQMS, I didn't have time to talk about it, but obviously we have a big component of actually particle physicists or fundamental physicists that really want to apply these tools and understand, if we can discover new particles. But some of the experiments that we have is, for example, what you are mentioning. We have some theorists that have some ideas about nonlinear quantum mechanics, and can we use some of these new tools to prove or disprove, if there is, some component of potentially nonlinear quantum mechanics. And so some of the experiments, we published a paper actually just a few months ago on this, setting kind of the best bound on this theory. So I think this is the exciting part. I mean, when you push technologies and you play with new technologies to the level that you never did before, then something new will come out.
May I add something? That's right. This topic is really interests me, right? I'm always mind blowing when I close to our fridges. I know, right? It's 20 centimeters from my hands and the quantum world. And to me, it's unbelievable to think of that one. And I have the questions. Yes, it's my ignorance, right? That led me using quantum mechanics to describe a system. You're right. When I measure the system, it becomes classical, right? Was it really superposition 0 + 1, or was always one or the other? The funny thing is that we tested quantum mechanics all the way we could, and it's always right. So we know that it's real. That is what is happening. What we have to change our point of view is that quantum mechanics doesn't pretend to describe, to tell us how the world is. It gives us a tool to explain the world. When we say particle, right, is a particle and waves, it doesn't really mean that it's both particle waves. It means that behave as a particle, behave as a wave. It's not pretending to tell us it's both, right? But if we use that concept, I would say it's a tool. The tool describes everything perfectly. And we haven't found a single experiment that proves that it's not correct. Even the famous experiment of Einstein, right, the PR, to prove that quantum mechanics it's wrong because there is the long distance interaction, it's proved to be right. Everything has been working. So it's just a model for us to understand what is happening, not necessarily a model to describe what really it is.
And it's probably not by chance that this year is the year of quantum and also the year of the Nobel Prize of Physics on quantum technologies that has made pioneering work in addressing some of these questions.
Yeah, interesting that the Nobel Prize this year was indeed from the community superconducting qubit community. Was both of three was in our community, so it was pretty exciting for us to see that. Right?
I think we have been running a bit out of time, so we will close the panel here. Of course, our panelists are still around, but I want to thank them again for the great interactions.
Okay. The ISSNAF Lifetime Achievement Award was created in 2014 to recognize individuals of Italian origin who have significantly contributed to research, leadership, and mentorship. Lifetime Achievement Awards recipients are invited to be part of a very small and prestigious ISSNAF group the honorary board of directors of our foundation. For the 2025 edition, I'm honored to recognize Professor Pietro De Camilli for his fundamental work on communications amongst neurons, the key cells in the brain and nervous system that communicate with each other, exchanging messages across a tight connection called the synapse. Professor De Camilli research pioneered the understanding of how this fundamental event is regulated through particular vesicles and chemical components involving both lipids and protein acting in the control of membrane traffic at the neurological synapse. The molecular principles he unraveled also apply to several other systems involving the endocrine and immune systems. His studies of synapses have also contributed to the elucidation of pathogenic mechanisms of human diseases, with recent emphasis on Parkinson's disease. Professor De Camilli is the John Klingenstein Professor of Neuroscience and Professor of Cell Biology at Yale School of Medicine, the founding director of the Yale Program for Cellular Neuroscience, Neurogeneration and Repair, and a Howard Hughes Medical Institute investigator. He has received many awards and honors for his work. He was elected to the European Molecular Biology Organization, received the Max Planck Prize, and then he was elected to the National Academy of Sciences and to the American Academy of Arts and Sciences. And he was awarded the Ernest Young Gold Medal for Medicine for lifetime achievements. Professor De Camilli has been a flagship representative of Italian science worldwide, played a constant and key role in fostering USA-Italy interactions, and is one of the founding members of ISSNAF. He has been a point of reference for Italian young scientists, training numerous young scientists that have accomplished successful professional careers. For all of his contributions, he is highly deserving of the ISSNAF Lifetime Achievement Award. Congratulations.
Thank you. So thank you very much. Thank you. Okay, thank you, Jezia, very much for this very kind introduction, and thank ISSNAF for giving me this award that came totally unexpected. Can I have my slides, please? Oh, I see. Okay, advance here. Oh, sorry. Good. Okay, so I vividly remember the trepidation when I first stepped on the plane to come to the United States a long time ago. I think it was 1978, and I feel very fortunate for the opportunities that this country offered to me. I feel like I had the best of both worlds. I think it was great to be educated to receive my primary education in Italy, to be receiving my first training in Italy, and then to come to this country where the environment offered me a lot of resources to really achieve my scientific dreams. I grew up in the north of Italy, and I spent my initial years between Milano, where I went to school, and the lake area Lago Maggiore, where I spent my summer vacation. And was this time during the summer vacation that the opportunity to be close to nature, to become interested in the mechanism of life, and really this year of vacation that made me determined to pursue a career in science. Although the studies in Milano, and in particular the Liceo Manzoni and then at the medical school, the Liceo Manzoni gave me a classical education that was really very important throughout my life. I work at the interface between fundamental cell biology and cellular neuroscience. Cell biology is the discipline that studies the properties of all cells. We are all made of cells, and cells can be highly differentiated in a multicellular organism. They acquire a variety of shape, a variety of function, but their function is really built on mechanisms which are fundamental in all cells. So the same fundamental mechanism have been adapted to support the existence and the life of cell with many different shapes, many different functions, etc. Particularly the neuron are the most specialized cells. They have an extremely complex morphology. This is a very simplified form. It can be huge cells. And as a cell biologist, I study the fundamental mechanism of life. As a neuroscientist, I study how this fundamental mechanism has been adapted to support the function, the highly specialized function of the nervous system. And conversely, I capitalize on some of the specialized function to learn about principle of general cell biological importance. Cells are compartmentalized inside by organelles. There are a variety of different organelles with different functions. They are anatomically distinct, but they are functionally interconnected in the same way as in a town, different buildings, different factories do different things, and then you have truck and car that move things around between buildings. In the cell, there are small vesicles as indicated here. They are surrounded by lipid that function as carrier to move things from one compartment to another in a process which we call membrane traffic. And throughout my career, I've been interested in elucidating about this mechanism, how these vesicles form, either bud from the donor membrane, how they know where to form, how they know where to go, how to recognize the membrane which we have to fuse to deliver the content. And if you want to understand the process, you need to have a good model system. And throughout my career, I used the neuronal synapse as a model system. Why the neuronal synapse? Sorry. This is a schematic illustration of a neuronal synapse between two neuronal processes, an axon of a neuron and a dendrite of the postsynaptic dendrite of another cells. The direction is from the axon to the dendrite. If you do an if you analyze this by electron microscopy, this is what you see. They are densely populated by small, homogeneously sized vesicles, and the function of this vesicle is illustrated here. This vesicle contains neurotransmitters. When an axon potential reaches the nerve terminal, there is a fusion of this vesicle with the limiting membrane of the cell, the delivery of the cargo to the postsynaptic cell, which upon binding the neurotransmitter, starts a new signal. And so basically the function of the presynaptic nerve terminal is to generate vesicle and to load this vesicle, then to make the vesicle fuse, to reform by a process called endocytic recycling. So it's a beautiful model system to understand the fundamental mechanism through which you form and traffic a vesicle within a cell. And I became fascinated with this model when I was a medical student in Milano at the CNR Center of Cytopharmacology, which was a fantastic environment to be trained in science. One of those places in Italy where this field of membrane traffic was being developed. And when it was time to move to the United States for an experience abroad, I decided to go to a lab where they pursue further understanding of this mechanism. And I joined the laboratory of Paul Gringer at Yale. We went on to have a Nobel Prize for his work on neuronal signaling. And in fact, I had two mentors. I have a real mentor that was Paul Gringer, in whose lab I was working, and another informal mentor, George Palade, that had been a founder of cell biology that made available to me all the equipment to study cell biology there, because the Gringer lab was not equipped to study cell biology. And basically, what I did when I arrived in Gringer lab, the first goal was to understand the composition of these vesicles. So in collaboration with other postdocs, we purify with dye purity the synaptic vesicle. We carried out the first biochemical characterization of their composition as shown here. This is highly purified synaptic vesicle from a brain, from an animal brain. And when I started my own lab, I became interested in understanding the step through which these vesicles are made, how they fuse, I reform by endocytic recycling and reloaded with neurotransmitter. And this is more or less what was known at the time. There was some idea, although there was still a little bit controversial, that the protein complex, including this protein here, chelatry, would assemble at the limiting membrane of the cell. When vesicle fused, this protein and this complex would assemble to induce a generation of a bud, which eventually become deeply invaginated, and eventually there is separation of this bud from the plasma membrane, from the limiting membrane of the cell to generate new vesicles that rejoin the cluster of vesicles negatively loaded with neurotransmitter. But very little was known about this mechanism, and in particular, this was obviously a very simplified cartoon. We wanted to understand all the mechanisms involved in these various steps. And I will give you here a few highlights. For example, we investigated, and this is just some of the highlights, we investigated the mechanism by which a bud can separate from a donor membrane. This from the reconstitution in vitro or the formation of this bud on artificial membrane, because we studied this process with a variety of approaches, with biochemistry, studied in cell, studies in animal, genetic studies. And this is a study in a cell-free system where we just generated artificial membrane at the cytosol from the brain, and you can see the beautiful formation of this bud. And then we discovered that you need a protein here to induce the separation of this vesicle. And this is the protein that we found assembled in a spiral form to generate a neck, which then, using the energy of ATP, induces the fission, really like a pinches, to cut the vesicle neck. And a beautiful demonstration of this property of the molecule is shown here, where we generated artificially lipid tubules, which are about 10,000 smaller than a millimeter. And then when you add this protein, it clips it in many pieces. This is really like a molecular scissor. Another example of what we found is what is shown here, that dynamin doesn't function alone, but function on a variety of accessory factors. And one of these accessory factors some of the accessory factors are proteins which have intrinsic membrane curvature that can assemble on a curved membrane as shown here. So they help to recruit this protein. In addition, this protein can themselves generate curvature. They're really membrane remodeling factors that are important to participate in the big membrane deformation, in the many membrane deformation that accompany the formation of this vesicle. And I would like to mention, as mentioned by Cynthia, that although these findings were made in a synapse, the idea was to learn about general principles in cell biology, and what I'm showing here turned out to have a major implication in every cell type of the body for a variety of processes. And for example, we found that when we identified this protein at synapse, we found then that this protein exists in a variety of forms in every cell, in every tissue, different sites within the cell, and are very important to generate membrane with various curvatures. So they're really important to shape the function of this organelle. Another finding was that the vesicle cycle between this fusion and what we call endocytic reaction, the lipids of the membrane, this is a lipid vesicle, undergoes some modification. And for example, there is an important lipid which is called phosphatidylinositol, which has an inositol ring at its end, can be modified by addition or removal of this phosphate at different points on this inositol ring. And this addition and removal generates a cycle, a metabolic cycle of this lipid that is nested within the vesicle cycle. And the additional removal of this phosphate is critically to allow the vesicle to progress to the different station. And then it turned out that this lipid is actually in every cell, and it can be phosphorylated not only at the two positions that I mentioned there, and 4 and 5, but also the position number 3. And so you can generate 7 derivatives from this compound, which are different distribution within cells, and we help define a code of membrane identity. So in this, what I said before, the organelles are interconnected by membrane traffic. This vesicle needs to go where to form, where to go, where to reach the destination. And the signature that they have on the surface, the lipid that they have on the surface, is very important to tell them where to travel and where to go. And finally, this work on lipid in membrane traffic made us interested in understanding how lipid reached their membrane to begin with. And so all membrane lipids are synthesized in an organelle, which is called the endoplasmic reticulum, shown here in green. And from the endoplasmic reticulum, they are transported to other places in the cell by this vesicular traffic, which I mentioned. But we found that in addition to vesicular traffic, they can also directly transfer lipid at the many contacts that endoplasmic reticulum for make these different organelles. And we have extensively investigated the protein, the function of this contact site, which are lipid transfer protein. They are protein that can extract the lipid from a membrane, hide an hydrophobic cavity, and then deliver to another membrane. So they allow them to travel what is an aqueous environment that doesn't allow lipid to be solubilized. And working in this field and in collaboration with a wonderful biochemist and structural biologist in my department, we identified a new class of lipid transport protein that directly function as bridges, allow the lipid to go from one membrane to another, exactly like a car can go from one street to another along the bridge. And this, which we identified over the last few years, is really a new concept of cell biology that turned out to be a very important general implication, because we found that this type of protein, we know now that there are many. By the way, this is the structure of one of these proteins shown here. They are long rods which have a very an hydrophobic groove inside. Hydrophobic means a surface that allows lipid to flow protected from the environment by this shell of the protein. And this protein exists at a variety of intracellular sites. So you see here a contact between, for example, between the endoplasmic reticulum and an organ called the lysosome or mitochondria, etc. They are critically important in orchestrating traffic of lipid within cells. But importantly, there has also been, as Cynthia mentioned, our work had interfaced multiple times with medicine. I'm a medical doctor training, although I always wanted to be a scientist, but I went to medical school, and I always cherished the possibility to see application of my fundamental work to medicine. And we have several opportunities to do that. At the beginning, for example, we found that some synaptic vesicle-associated protein can become target of autoimmunity and be responsible for neurological diseases. More recently, we have capitalized on the major progress that medical genetics has done. Medical genetics is the discipline that studies genes responsible for different diseases. And what the genetics do, they identify genes that are important for Parkinson or for Alzheimer's or for any other disease. But when the gene has been identified, we only have a name, we don't know what the protein does. And the job of cell biologists figure out what this protein does. And we've been very fortunate that some of the proteins that have been identified, including gene whose mutation are responsible for neurodegenerative diseases, are actually proteins which are at the core of our research. I go back to this figure here. This protein here that we identified and characterized is a gene that, when mutated, creates familial form of Parkinson's disease. And so we've become very interested to help elucidate mechanism in Parkinson's disease. We are now part of an international network to understand the mechanism of action of this gene. Obviously, the ultimate goal is to cure disease. We are not there at the stage yet. We are still at the stage of understanding the mechanism through which mutation this protein create pathogenesis, but this is obviously the critical step for the future to develop the therapeutic approaches. And finally, I would like to say, as I look back on my scientific career, I feel like I've been fortunate to work in an era where there has been a tectonic change in the understanding of mechanism of life. I started out in the late 70s when the field was stuck at the level of description. George Palade, that was one of my mentors, had just gotten a Nobel Prize for understanding membrane traffic in cell, but in a very descriptive way. They learned where a vesicle comes and where it goes, but we have no understanding of mechanism. Throughout these few decades, there has been this tectonic change that I mentioned, and now we have the possibility to understand this mechanism at the atomic level. And I feel myself very fortunate for having been able to work, for having had the opportunity to work in this era and to participate in the development that occurred during this era. And finally, I've been very fortunate to live in a time where funding for research, for basic research, was expanding, particularly in this country. I've been generally supported since 1992, and I'm still supported by the our U.S. Medical Institute. I've been generally supported by the NIH. Unfortunately, the landscape now is changing, as you know, at least for NIH. And so now it's going to be more of a challenging era, particularly in this country. And this maybe is an opportunity for Italy to do something to bring back home some of the scientists that came abroad. And throughout my career, I've I kept always in contact with the Italian community, part of advisory board of foundations and of institute, and I saw how much potential there is in Italy, how much good science there is there. And really, I hope that at this time there may be a possibility to bring people back. A couple of weeks ago, I visited as member of the advisory board the Technopole in Milano. I'm amazed by the facility developed there, and I really hope that this moment that can coincide with the Renaissance in it. And finally, I would like to mention that obviously this work doesn't develop in isolation. I'm very fortunate to have had many collaborators. Many of them has gone on to have leadership responsibilities throughout the world. Many postdoc, graduate student, support personnel, and these people not only did things because I told them to do, they really helped the direction of research. As you know, in a lab, the partnership between a mentor and trainee is absolutely fundamental. And I always encourage independent thinking in the lab. This has been a fantastic attitude that led me in direction that I never thought I could pursue. I would like to acknowledge also, I had many collaborators. There are 3 people that I would like to mention that have been long-term collaboration. Ryan Ariani initially for the work on synaptic vesicle, Tim Ryan for the work on synaptic vesicle recycling, and Karin Reinisch for a structural role on lipid transport. And last but not the least, my mentor, Jacopo Mentolesi, that introduced me to science in Milan. He was a fantastic, enthusiastic scientist that really helped me to confirm my decision to become a scientist. And then Paul Gringer, George Palade, 2 major figures in science, both Nobel Prizes. Paul Gringer was my postdoctoral advisor, and George Palade, the person that recruited me as an assistant professor to the Department of Cell Biology at Yale. And I have to say, I credited them not only for having taught me a lot of things, but for having instilled me the self-confidence, which is essential to have a successful career in science. Thank you.
Welcome back, everyone. Thank you for coming back. Now we are, as the chair of the Scientific Council of ISSNAF, it's my great pleasure to start the ceremony for the Young Investigator and Innovator Awards. For nearly 15 years, ISSNAF has annually presented the Young Investigator Awards to outstanding early career Italian researchers and scholars in the United States and Canada. Spanning a wide range of disciplines, these awards honor innovative work that drives forward technologies, discovery, and research in their respective fields. The awards that are going to be assigned this year are the Embassy of Italy Award, that this year will be focused on research in quantum technology, the INFN Bruno Tuschek Award for Research in Fundamental Physics, chaired by Patrizia Rossi from Jefferson Lab, the Mario Gerla Award for Research in Computer Science, chaired by Leila De Floriani from University of Maryland, the Paola Campese Award for Research in Hematologic malignancies, chaired by Alessandra Ferraioli, MD Anderson Cancer Center, and the R&D for Culture Award for Innovation in the Study of Italian Culture, chaired by Franco Pierno, University of Toronto. For the award, as a little bit of background, the nominees should have an Italian citizenship, should have a current affiliation with a research institution in the United States and Canada, and should have received a PhD or an equivalent degree in 2018 or later. This year, we have received an outstanding number of applications. The different committees have had really hard time selecting the finalists. Each award has selected 3 finalists that are present here, have presented posters this morning. As you have already seen, all amazing scientists and research, and even more to select the winners. The winners receive a prize of $3,000. I have the pleasure of chairing the Embassy of Italy Award for Research in Quantum Technologies. The Embassy Award has been established in 2020 And this year's edition recognizes outstanding contributions from Italian researchers in the USA and Canada, active in a broad field of quantum technologies, recognizing groundbreaking contributions and research that advances our understanding and application of materials, algorithms, and platforms for quantum computing and sensing and imaging. My job as a chair has been coordinated by Dr. Stefano Lami from the National Quantum Information Research Center and Professor Alberto Salleo, Stanford University, that are part of the jury, and also several referees to screen all the nominees and select the finalists. In particular, Massimo Ruzzene has helped in this role. The finalists that have presented their posters today are Dr. Marco Colangelo, an assistant professor at Northeastern University, for his work titled High Performance Superconducting Detectors for Quantum Information Science Applications. Dr. Gabriele Pasquale, a postdoctoral fellow at Harvard University, for his work revealing and controlling quantum matter for next generation devices. And Dr. Giovanni Scuri, Bloch postdoctoral fellow at Stanford University, for integrated quantum photonic devices for sensing, networking, and information processing. I have to say that the selection was very hard. Probably my fellow award chairs will say the same next. In fact, the jury was split equally. Eventually, we had to converge on a winner, and this year's winner is Dr. Marco Colangelo. Congratulations. He has been selected for his remarkable contributions to the field of quantum technologies, addressing the important challenge of realizing reliable and efficient detection of single photons for building scalable quantum information processing architectures. Congratulations.
Thank you so much. I'm really deeply honored to receive this award. Thank you to ISSNAF. Thank you to the Embassy of Italy. This is really amazing. And in my day-to-day life, I really try to build a infrastructure that can help making quantum communication and quantum computing something that we can really do and deploy. And it's really even more honoring to receive this award this year, where also the Nobel Prize was given in physics was given to quantum technology, and also it's the year of quantum. So it's maybe even more, even in a way more honoring. So thank you so much again to ISSNAF, to the Embassy, and to the organizer, to the juror for this award. And thank you so much.
I would like also to invite the counselor to have a picture together. And now it's my pleasure to introduce Professor Patrizia Rossi to present the Tuschek Award.
Okay, good evening. It's my pleasure to be here today and present the Bruno Tuschek Award for Research in Fundamental Physics. And this award was established in 2022 by INFN, Istituto Nazionale Fisica Nucleare, and we are really grateful for the generosity of this award. And this award honors the memory of Bruno Tuschek, who, for his pioneer work in not only particle physics, but also accelerator physics. And we have the first electron-positron collider in Frascati. I'm very proud to present this work because I am a person working at INFN in Frascati. So we received, as Andrea said already, a substantial number of outstanding applications. It was difficult to make the selection, but with my colleagues, Alessandro Ratti and Elena Orlando, at the end, we came to a common agreement. And here are the three finalists for this award. Dr. Francesca Bonati, with the research title Connecting the Structure of Atomic Nuclei to Neutron Stars. Dr. Giulia Cerini, with the research title Galaxy Clusters as Cosmic Colliders for Cosmology and Dark Matter. And Dr. Antonella Palmese, with the research title Gravitational Waves as a New Cosmological Probe. And the winner of the Bruno Tuschek Award this year is Dr. Palmese, Antonella Palmese. And Antonella, come here. And before taking the picture, I want to read the motivation for your award for pioneering the integration of galaxy surveys and gravitational wave astronomy, and for playing a leadership role in developing a new cosmological analysis technique with the aim of constraining the Hubble constant using the dark science method. Congratulations, Antonella.
I'm truly honored to be recipient of this award. My work on a day-to-day basis focuses on trying to measure the expansion of the universe using collisions between black holes and neutron stars, and specifically through observations of gravitational waves and also electromagnetic radiation from large telescopes. And I'd like to thank ISSNAF and the embassy for organizing and hosting this fantastic event. Truly a great networking experience, I would say. And also I would like to thank the jury for all the hard work, and also ISSNAF for making this award possible. Especially, it's very important to me since that's how I started working on cosmology, working with scientists from ISSNAF back in Rome. Thank you.
We have, okay, on the podium, please, Dr. Francesca Bonati. Dr. Giulia Cerini. Okay, and now it's my pleasure now to invite Professor Lelia De Floriani to the podium to present the Mario Gerla Award.
Thank you for your introduction, and good afternoon to all of you. I am really honored. It's a great pleasure here to present the 2025 ISSNAF Young Investigator Mario Gerla Award for Research in Computer Science. The Mario Gerla Award was established by the family in 2019 to recognize the young scientist in computer science, and is in memory of Professor Mario Gerla. Mario Gerla has been a pioneer in computer network. He was a professor at UCLA, University of California, Los Angeles, and an ISSNAF founding member. I actually want to take this opportunity to express my deep gratitude, and I think of all ISSNAF, to the Gerla family for their generosity in sponsoring this award, for their continued support that have been inspiring to all of us in all this endeavor. I also want to thank my other two members of the jury, Professor Elisa Bertino, who is a member of the ISSNAF board, and Professor Filippo Menzer, who is a member of the Scientific Council of ISSNAF. This year, we received an impressive number of applications, very talented young scientists. It was actually really a pleasure to look at all the application. And as my colleagues already said, those it seemed to be common to other awards. The work, the job was very challenging. So after some effort, we actually identified three finalists, three very brilliant young researchers that actually impressed us with their fantastic achievements. And I hope you had the opportunity to visit the poster and to talk to them this morning. The three finalists are Dr. Antonio Loquercio, who is assistant professor at the University of Pennsylvania, Dr. Riccardo Paccagnella, assistant professor at Carnegie Mellon University, and Dr. Tiziano Picardi, assistant professor, just started at Johns Hopkins University. And now I'm pleased to announce that the winner of this 2025 Mario Gerla Award is Dr. Antonio Loquercio. Let me read the motivation. Dr. Antonio Loquercio research enhances the performance of complex robotic systems by focusing on the pivotal role of perception in building effective world models for decision-making. He has demonstrated that even simple perceptual models can enable agile drone flights and explore how robots can use their own sensor data to refine their world models. Congratulations.
Thank you so much. I'm very excited, very delighted to receive this award, in particular because as soon as I open my mouth, people realize I'm Italian. And as I was younger, this used to annoy me. But now I grew up to see that this is actually one of my biggest strengths. Italy, dedication to excellence, as the ambassador said before, holistic view is really what makes, I think, my research unique. Just closing up, I would like to thank ISSNAF and the Embassy of Italy for hosting us, the Gerla family for sponsoring this award, and finally my mentors that taught me what robots can learn, and my family and partner Noemi, which taught me what robots cannot learn. Thank you very much.
One second, I'm coming.
Oh, yeah, surely. I was keeping myself. Yeah, I was happy to keep it. So now let me call to the podium the other two finalists. First, Dr. Riccardo Paccagnella. And congratulations. And then finally, Dr. Tiziano Picardi. Tiziano. And now it is my pleasure to introduce Professor Paolo Strati, who will present the Campese Award.
Good afternoon, everybody. As you heard, my name is Paolo Strati. I'm an associate professor in the Department of Lymphoma and Myeloma at the Anderson Cancer Center in Houston, Texas. And I'm honored to announce today, on behalf of all the committee members, the recipients of the 2025 ISSNAF Young Investigator Paola Campese Award. Established by Stefania and Vito Campese in 2011, the Paola Campese Award for Research in Hematological Malignancies is in memory of their young, talented, and generous daughter, Paola. We are delighted to share and celebrate the outstanding finalists for the 2025 edition, of interest all coming from Dana-Farber Cancer Institute, Nicoletta Cieri, Sara Piccinelli, and Maria Caterina Roti. It's been also for us a very hard task to identify the winner. Please believe me, you all were amazing, and we wish we could have given multiple awards. But we are excited to announce that the recipient of the Paola Campese Award 2025 is Dr. Maria Caterina Roti from Dana-Farber Cancer Institute in Boston.
Thank you very much. I'm truly honored and humbled to receive this award. My research focuses on engineering immune cells and redirect them to attack more specifically cancer. I would like to thank the embassy for the hospitality, the Campese family for sponsoring this award, and ISSNAF. Thanks to this application, I had also the opportunity to learn more about the society, and this is an honor being here and a great connectivity and connection experience as well. Thank you very much.
I didn't fall, that's great. I would like to share the reason, though, why we selected Dr. Roti. Dr. Roti has been selected because of her leading role in a project aimed at engineering a novel membrane titer version of the adapter molecule SLF76 that lowers the activation threshold for CAR T cells, recently accepted for publication on Nature Cancer with Dr. Roti as first author, and recently also licensed by a biotechnology company in light of the very promising activity of such platform. Low expression or complete lack of expression of the target antigen is becoming a highly unmet need in the field of cellular therapy for hematological malignancies, and the robust experiments performed by Dr. Roti pose the base for the next generation of clinical trials that ultimately result in better outcomes for our patients. So thank you, Dr. Roti, for the work that you have done. Thank you again. Unfortunately, Dr. Piccinelli cannot be here today, but I would like to call to the stage the other finalist, Dr. Nicoletta Cieri. I'd now like to leave the stage to Professor Gianni Cicali to present the R&B for Culture Award. Thank you.
Thank you very much. It is indeed my pleasure to present the finalists of a very excellent cohort of applicants this year, like in the other case it happened. And the finalists are Sarah Galli, who is an international lecturer at Dickinson College in Carlisle, Dr. Cristina Carnemolla, who is assistant professor at McGill University in Quebec, Canada, and Dr. Luca Zipoli, who is assistant professor at Bryn Mawr College in Pennsylvania. The research of Sarah Galli, after due consideration has been chosen as the winner, and Sara Galli's project aims to create an educational platform for teaching Italian to North American students. The platform will address all the needs arising from the social implication of contemporary language use, including gender-related consideration and other aspects. I wish to mention also the beautiful researchers of the other finalists. Dr. Zipoli research on globalizing the Renaissance, cultural exchanges in early modern Florence, 1439, 1492. That is a very familiar date in this country. And Dr. Cristina Carnemolla project is Harvesting Truth, Southern Realism as an extractivist aesthetics. Sorry. And, sorry. And I'm calling on the podium, Dr. Sara Galli, please. Congratulations.
Well, it's quite an emotion. Thank you. Like, I'm very honored, and it leave me like almost speechless. It's quite rare for me. So thank you to ISSNAF. Thank you to the embassy. Thank you to the sponsor who like support this prize. I mean, with my colleagues and like all the people that join me in this journey, we'll try to make like the classroom a safe space for everyone, where everybody is included, welcome, and feel safe. And I think it's very important and across all the research field. So I just finish and conclude and thanks to my colleague at Italian Studies at Dickinson. They support me, the colleague that across the languages, they decide to strive with me to make like the classroom more inclusive. My colleague and co-author, Mohammed Jamali, is not here. And I want to dedicate my award to my beautiful queer chosen family. They always support me and believe in me even when I didn't. And my student who always pushed me to become best teacher, and to my nonna, that I'm sure she's smiling now, like somewhere up there. Thank you so much, everyone.
And I would like to call on the podium for a picture with all of us, the other finalists, Dr. Zipoli and Dr. Carnemolla. Are you there? Yeah. Oh, yeah. It's not mine.
This is my dad.
Oh, sorry.
Oh, sorry.
Please, Cristina.
Yeah.
Chris Luca, molto piacere.
Yeah. We want to like us.
No. Oh, yeah. Okay.
Thank you.
Tutti insieme?
Everybody together?
Why not?
We're almost. The humanities guys. Yeah. One, two, three. Beautiful. Thank you.
Thank you.
Thank you.
Thank you. I would like now on the podium Professor Zappacosta for the 2025 Innovator Award.
Actually, we are ahead of time, so we can spend the next half hour doing this, right? Okay. Actually, I'm Pierluigi Zappacosta. Professor De Camilli and io we are the two co-founders of ISSNAF present today. But this is, usually there are not that many. So we are here to for the first edition of the newly created ISSNAF Innovator Awards series. Cynthia spoke about that, and but it's something new that we want to emphasize at ISSNAF, an emphasis on innovation. And these awards are intended to recognize individuals of Italian origin working in North America who have demonstrated excellence in scientific research, successfully translated into entrepreneurial activity or commercial innovation. We are thankful to TEF for sponsoring the first ISSNAF Innovator Award that we call the TEF Award for STEM Innovator, targeted this year at the robotics community. Tech Euro Foundation, TEF, is a non-profit foundation based in Milan, dedicated to supporting deep tech researchers and founders through their journey from lab to market, and young entrepreneurs as they grow into founders. I also like to thank Marco Pavone and Silvio Savarese for participating in the selection committee. It is my pleasure to present the TEF Award for STEM Innovator to Professor Francesco Borrelli. Francesco Borrelli is a professor of mechanical engineering at UC Berkeley, and he currently serves as Chief AI and Robotics Officer at Nextracker, a global leader in solar power plants. His work bridges academia and industry and sustainable energy. He earned his laurea cum laude from the University of Naples Federico II in 1998 and a PhD from ETH Zurich in 2002. He co-founded two technology companies, Brightbox Technologies in 2013 and WhiteSense in 2019. Francesco Borrelli's work continues to shape the future of autonomous mobility, robotics, and sustainable energy, blending rigorous theory with transformative industrial application. Congratulations, Francesco. Actually, we need that. We allow you to come.
Good evening, everybody. Honored to be here. Thank you to the TEF Foundation. Thank you for ISSNAF for selecting, gave me the honor of this award. Thank you, the ambassador, for hosting. I am honored. It means a lot as an Italian scientist among all these distinguished scientists. I was 35 years ago a teenager reading sci-fi books and dreaming about robots and cars in south of Italy, suburb of Naples. Yeah, I am acknowledged for the impact that my ideas and techniques have had out there. Okay, so it means a lot. I spent 35 years or a bit less trying to design technology that bridges tiers and applications for a better society, safer cars or green energies. Kind of succeeded. My techniques are in millions of vehicles out there. Today, I'm the chief of a company that delivers a gigawatt a week of solar energy. And we have delivered 100 gigawatts. Just to give an idea, California needs 50 gigawatts to run. So we have already delivered 150. And every week, we deliver 1 gigawatt. This is from Statue of Liberty until Central Park of solar fields. Okay, so my role with robotics and AI is to make sure that we reach a terawatt, and I look forward to new challenges. I was given only 1 minute. Again, thank you, ISSNAF. It reminds me, this award really means, it reminds me how important it is to bridge university research with academia and the role that we Italians have in this process. Thanks again for the role that ISSNAF has in connecting people with opportunities and ideas. And thank you again for this award. Thank you.
So I thought I would have messed up something. I forgot to recognize the very talented finalists of the Embassy Award. And if the counselor is available, we'll take pictures as well. Dr. Gabriele Pasquale and Dr. Giovanni Scuri. We will close the ceremony with the president, Dr. Cinzia Zufara.
Just a few words to thank you all again. I hope you have all enjoyed spending time with us today, mingling with a variety of highly successful, productive researchers, make new friends, learn about ISSNAF, and I hope you take this opportunity to go out and help be part of our mission as you continue in your career. It has been a pleasure seeing you all today here. Thank you.